All right, well, this is Astronomy Daily Live, and it is once again 2 hours UTC. We meet here every single day. On rare occasions, I have to cancel or postpone, but pretty much every single day I'm here, and many of us come in and gather together in this circle of friends, sort of like a virtual porch, right? Where we're just sort of sitting out on the porch, and it's starting to get dark, and it's a nice cool breeze, and at least where I am, the end of the day, and just time to sit back and sort of relax. And it's like, well, don't want to watch the TV, don't want to hear about any of the news. I want to look up, right? I want to look up and think about the universe and my little place in it. So that's really what this live stream is all about. It's just sharing a passion, sharing the passion that I've had my entire life, and it's it gets more and more and more intense as time goes by. So by the time I'm 100, man, I don't know how insane I'm going to be about all this. Who knows? Because I've been riding this rocket ever since I can remember, right? I mean, and I'm still pretty vertical, right? Just shooting straight up. So I'm gonna check the chat here really quick, see who's in. I see that Bobby's back on the panel. Hey there, Bobby.
Nothing much. How you been?
Everything's good. Everything's good. It's actually sort of clearing up here, which means I've sort of got the itch, right? I've got the itch because I've got this thingamajigger here, the Badenoff mask, and I've got my focal reducer, and it's like, I'm sort of chomping at the bit. Now, what I really should be wanting to do is actually collecting more data for my photometry project. But, I'm still sort of working on the software on that, and things are actually looking pretty good there. So, maybe I'll give another report on that when I have more to talk about. So, in the chat, Uncle Bill is in the chat. Bob Dog is in the chat.
Welcome.
Atta is back in the chat, and Tom so far. So hey, nice to see everybody there. I've got some coffee here tonight, so cheers. And of course, I've also got the HOH, hydrogen hydroxide, both an acid and a base at the same time. How can that be? It's like having heads and tails on the same side. It's just.
You gotta show me how to do hydrogen hydroxide.
What's that?
You gotta show me how. You gotta show those people how you do hydrogen hydroxide.
Oh, I make a new batch of this every so often, and it's great. It's just I've got a big vat of it, right? Like buried in the ground, right? And it's all I have to do is sort of turn on a spigot, and out it comes, and it's great. So yeah, I do have to make a batch from time to time, but I try to make some pretty large batches. So I've always got a lot on hand. So cheers.
Yeah.
So yeah, go ahead.
Your favorite beer.
This is I have always liked just plain old this, right? I mean, um, when when I'm been working outside, say, and I'm sweaty and I'm hot and I'm tired. It's you know towards the end, right, of that work, I am thinking of one thing, and that is this. That is this. So, to me at least, there is nothing more refreshing than good old hydrogen hydroxide, or if you prefer, dihydrogen monoxide. So they're both excellent, highly recommended, and yeah, if you can get it in a nice sort of clean, pure form, you usually the only way to do that, right, is to sort of brew up your own, right? If you're getting it from another source, there might be contaminants in it and everything else, and I'm not saying that this is 100% HOH, right? This has got minerals. It probably has bacteria. It probably has viruses. It probably has all kinds of things in it, right? Microscopic things. If I took a drop of this and put it under a microscope, never, I would expect to probably see some pretty interesting things. So, this is definitely not pure stuff. I don't necessarily know if the pure stuff is all that great. I mean, once in a while, yeah. But I sort of like the home brew. So cheers. Never touched this stuff, huh, Anta? All right. So what I thought I would do today is a little bit of astro-art. I like to make art with various kinds of astronomical data. And what I thought that I would sort of walk us through tonight is, maybe like uh, some of the process, and sort of follow our noses a little bit and see where it leads. But what I thought I would start with is take the orbit of the Earth going around the Sun and the orbit of Venus going around the Sun, and see what we can do with that. Excuse me. See what we can do with that. One of the things that I can do is for instance, for each day, right, each Earth day, I can determine the position of both the Earth and Venus, and I can draw a line in between them. And then the next day, I can do exactly the same thing. I can draw a line in between those. And the next day, and the next day, and the next day, and the next day, and the next day. And do this for, I don't know, a year or two or three or 10, whatever. And, draw all these lines and see what kind of pattern it makes. The other thing that I thought I could do tonight is instead of drawing a line in between those two things, calculate the midpoint, which is basically, between Earth and Venus, it's basically the barycenter. The barycenter is the center of mass, right? So the Earth and Venus are basically the same mass. So the Earth-Venus barycenter is going to be more or less right in between them, right? So I sort of thought that we could do at least those two things, and then maybe, you know, try to colorize some stuff. I don't know. You know, let's just you know, turn on our creative uh, channel here and see what we can do. So the first thing that we have to do, of course, is we have to get our data. So the best place that I've found for that is the JPL Horizons website. So I'm going to share my screen, and I think I've shown this before on a live stream. Oh, I'm watching my my satellite loop here, and in fact, while we're watching that, I'm going to start up my smartphone to watch the live stream so I can monitor all the shenanigans. Let's see, like that. Here we go. So I'm in southeastern Arizona, so I'm down here, and as you can see, did I just reload this? I don't remember if I did or not. As you can see, got this sort of this mass of clouds here, and what this is the infrared view. So what I'm sort of worried about is this little clump right here that's starting to move north, just starting to cross the border, you see, and those high clouds are going to be a killer. So it's sort of looking like, in the next hour, those things are going to be moving in. So, I'm probably not going to be able to see much tonight. All right. Anyway, let's go over to the JPL Horizons website and get this all set up. So let's get the Earth data first, and let's do about like maybe I don't know. Let's do like 10 years worth of data. All right. So let's set this up. What we're going to do is we're going to get the position of the Earth relative to the sun every single day for 10 years. All right, so that'll be what, about 3,600 data points or so, and that's going to be pretty good resolution. We can mess with the resolution later. It's always best, you know, to start with the highest resolution that you can, and then you can always knock that down, right? So we're going to change this to a vector table, like that, and let's see. The target body is going to be Earth. So I'll just do a search for Earth here. Earth. And please try again. What? No. Okay, let's do it this way. Sun and planets, display list, Earth. There we go. Okay, so, and that is the geo center. So that is the center of the Earth, right? So then our origin is going to be the sun, and I think I should be able to do a search for the sun here. Yeah, there we go. Okay, so sun, body center, all right? So now we want to do a time span and a step size. So let's go from, well, let's just do it today, right? And let's go 10 years out. So 8, 28. And in fact, I'm gonna do this too, just because I'm gonna start at 0 hours UTC and end on 0 hours UTC. And I'm gonna change this to 2028. And our step size is gonna be 1 day, right?
That's going to be a lot.
Yeah, well, you know what, 3,653 data points. That's actually not very many. I mean, you know, I'm used to dealing, you know, with you know, millions and millions of data points. So, you know, 3,600, nah, nothing. Okay, so let's specify that time. See, so that's changed now, right? So now let's let's see what we've got here. What we want to do is, I think we want let's just do just the position. So X, Y, and Z relative to the sun. I think that's all that we have to do. Now we have other possibilities, right? We can look at the velocity also. We can look at the range, the distance, a bunch of different options here. But I think for these purposes, it's all we need is the XYZ position. So let's do that. And let's see, astronomical units, let's do it in kilometers. The reference plane, yeah, I'm just going to leave all this, I think, default. It's not going to make that big of a deal. Include object information, yeah, whatever. Okay, so let's use those settings. And the display output, let's make it a plain text like that. Okay? So it's going to be vectors. Earth is our target. The sun is the origin. We're going to go from today to 10 years from now at a step size of 1 day. As I said, this is pretty high resolution, but we can always knock that down with the software that we're going to write, so no problem. Okay, so let's generate the ephemeris, and what that'll do is that will give us that, and I think I want to change my format a little bit. I don't want it like that. I want it with commas. Let's see. Here we go. Comma separated variables. Okay, let's do that. Because I'm going to write a Perl script that I'm going to use to actually parse all this information and all that. So I want the output to be as simple as possible. So yeah, so here we are. Here is the Julian date, the calendar date, and the X, Y, and Z position of Earth relative to the sun. And these units are in kilometers, right? So 136 million kilometers in X, and then a negative 65 million in Y, and then a positive, what is that, 2,500 in Z, right? This E plus 8, that's like saying times 10 to the 8th. And this is saying times 10 to the 7th, and this is times 10 to the 3rd. So as you can see, our Z position is really small compared to the X and Y. We're basically orbiting the sun on a flat plane, more or less. So here's all of our data points, right? So I'm going to grab this whole thing like that. I'm going to copy and I'm going to paste it into a text file. And let's call this Earth, I don't know, 1828. Okay. So then I'm just going to paste this into here. And that'll take a couple of minutes. We can kind of fun to watch the date go.
Cosmic, sometimes in Linux, and sometimes if you specify the .txt, that's how I do it with my when I do my radio room decodes. I usually copy it, paste it from my FLDG, paste it on a graphical text editor.
Mm-hmm.
I saved it as like a plain text file, so most of the times you have to specify that .txt or it doesn't want to work.
I don't have that problem. No problem at all. Being a programmer, I've been doing this for about 1 billion years. So yeah, that I don't have to specify extensions of any sort unless I want to. Doesn't matter. Don't matter. So we're up to 2025, 2026. Slowly, slowly filling in all these dates. So this is the position of the Earth relative to the Sun every day for 10 years. So it takes a little while to fill this in.
I like know what Atalanta always drinks.
What does she always drink? Shenanigans, yes. All right, so I got rid of the bottom stuff. I'm gonna get rid of this top stuff. There's actually, some pretty useful information in here too, right? They talk about how much like the atmosphere weighs, and how much the ocean weighs, and how much the crust weighs, and all, sidereal days and densities and all kinds of interesting information there. But I'm going to get rid of it all because we don't need it. So all we need is this data. Like that. Okay, so I'm going to save that to that file. And, let's plot this as is, right? Let's just sort of see what we've got so far. So I'm going to start up my favorite plotting program called GNU Plot. And I'm going to look at this file again. So my separator here is commas, right? So I have to tell it that I'm going to separate things by commas. Otherwise, it's going to look for spaces in between all of these. That's what it defaults to. But I can tell it to do that by commas. And let's do a 3D plot. So 3 of those, Earth 1828, so it's going to be column 1, 2, 3, 4, and 5. 3, 4, 5. Let's just do it with lines at this point. Line width, I don't know. And line color, let's just make it black. Okay. So the z-axis here is highly exaggerated, right? But that is actually the inclination of the Earth relative to the Sun. And so you can sort of see on the bottom here is X, and here's Y, and here's Z. And 0, 0, 0 is, somewhere in the middle of this ring. And as you can see, the path of the Earth is a little wobbly, and pretty inclined. It's not huge, right? I mean, if we were to do this to scale, right? If we were to scale the z-axis exactly the same as the x and y, let's do that, right? It's going from negative 1.5 times 10 to the 8th up to 2 times 10 to the 8th, sort of in both axes here. Let's make sure, is this, I don't know if this is x and y or if this is x and y. I don't know. Let's experiment here a little bit. So let's assume that x is going from 1.5 to negative 2, which I don't think it is, but let's find out. This is part of the messing around part, 2E8. Whoop, 2E8. Did that completely get rid of things? No, it didn't. Okay. So let's do exactly the same thing. Well, not exactly the same thing for y. It looks like it's sort of reversed, right? Y goes from positive 1.5 to negative 2. So in the y, we'll go 1.5 E8 to negative 2 E8. sure that we've got our... Okay, so there we go. So now let's make Z exactly the same, right, as these other two. And you'll see that you're not going to be able to see any kind of wiggling at all. Let's just go from from negative 1.5 E8 to 2 E8. And you will see that it's all that we're going to get is a nice flat flat ring, right? Because as you can see here, Z is going from what, maybe negative 10,000 kilometers to maybe a positive 10,000 or so. So it's really, really, really flat relative to the X and Y, right? This is absolutely huge. And of course, from, let me get this so it's circular here, 180. Here we go. Now, let me square this up to, we want sort of nice round figure here. So right in the center here would be the sun, right? At least approximately in the center. And this is 1 astronomical unit from the sun to the Earth, right? And it's kind of hard to tell here. You know, what we can do is we can actually create a sun position at 0, 0, 0. Yeah. I guess I have to put that between commas. It wants to see commas. Now, we can also plot the sun using... Oh, I'm having to type one-handed here, which is always fun. Let's make that a point. Points, point type 7, color 7. And point size, let's make it a little big so we can see it. 3. So there's where the sun is. And I made the sun a little big. It's definitely not to scale by any means, but you sort of get an idea, right? And that's a pretty circular orbit. I'm going to try to... I'm not exactly sure how circular it is, but that sun is pretty close to the center of that ellipse. Now, it is an ellipse, but it's not much of an ellipse. It's pretty round, all right? Pretty round. But yeah, it's a pretty wobbly orbit too, which is kind of cool. Okay. All right,
That's
so let's...
interesting too.
Yeah. Well, and I mean, has anybody figured out what the wobble is? Think about what that is. Why there's a wobble. I'll let you think about that for a while. We're going to do exactly the same thing for Venus. And the only thing I have to change is the target body. I'm just going to go to Venus instead. Okay? Everything else is exactly the same, right? We're going to do exactly the same dates and the same output, all of that. We're just going to do Venus instead. So let's generate that ephemeris. And we'll copy that. And quit out a GNU plot for now. And let's make this Venus. And we'll paste that in. And you might notice right away that the numbers are different and they should be a little smaller. Kind of interesting. This number looks bigger. I guess the inclination of Venus is more than the inclination of the Earth. Don't know if I knew that or not. while that's loading, I'm going to take a sip of this coffee. And maybe I can check the chat too.
Check.
While this is loading, check the chat. Okay, cool. More shenanigans, just don't tell me. You know, that's what I tell everybody. It's like, you know, if you're going to do stuff, you go ahead and do whatever you want. Just don't tell me. So these numbers are changing really fast. See how they're going? You can sort of watch them go here. All right, that's done. So I'm going to get rid of all this stuff at the end. And I'll go back up to the top. This editor, by the way, that I use is called VI. And it's you know, one of many. I like it. Okay,
I use a graphical one.
Yeah. Whatever works. That's my attitude. All right. So what I'm going to do, the one problem with this windowing system that I've got is that it really doesn't like to wrap lines really well. So what I have to do, unfortunately, is I sort of have to zoom out so my font goes a little bit smaller. So let's do Venus here. So we're going to keep the same scale, the Earth scale. Actually, you know what? No, let's completely get rid of that so it just auto scales. It will figure out its own scale. So
does it keep that CSV configuration?
Actually, no, it doesn't. I'm gonna have to tell it to do that again, but I can do that afterwards. I'll let it scream at me, and then I'll do it on the next line. So let's do a line color of I don't know. I forget what the colors are. In fact, we can specify an RGB color. I think like this. Let's do red for this one, and we'll do green for this one. RGB color. Let's do red and blue. How about that? And we'll keep sun at whatever it was. Line color 7. All right, so it's going to scream at me because it thinks that it's looking for a different kind of separator, but now I'm going to tell it that it's commas, and now we should be all right. Bam. Whoop. What did I mess up with? RGB color, is that supposed to be in quotes? Might have to be in quotes. Sometimes I don't remember how this exactly works. I gotta do it a couple times. Oh. So there's the, and let me square this up again a little bit here. Let's see. Okay. So I'm gonna make the square square. I don't care what the ellipses are. I sort of just want to make that square as square as I can.
Now the blue line is Venus and the red line is Earth, or that's different.
Correct. That is correct. Yeah. And you can see that there is quite a difference between the inclination of Venus and the inclination of Earth. Now, this is highly exaggerated, right, because of the scale here. Again, you know, if I were to change the z-scale, and I'm going to get into trouble here with my line wrapping, but let's do it anyway just for fun. If I change the z-scale to the x and y scales, then you can see that these are going to be pretty much in the same plane, right? Pretty much. But Venus is for sure more inclined to the sun than the Earth is, which I don't think I knew that. But let's leave this exaggerated for now, because it'll actually make the effect a little bit more interesting. So now instead of lines, let's do points instead. So I'm going to get rid of the sun. And let's see. Let's do points here. Point type 7. Point type 7 is just a circle, right? It's just a dot, as opposed to a square or a plus sign or a diamond, or, you know, there's lots of different point types in here. But we're just going to stick to that. Point type 7 with points. This is pretty much going to look exactly the same. Oh, let's specify a point size. Point size of 0.1. And let's put point size here. So this should look almost exactly the same because the points are so close to one another. Yeah. Yeah. Now, what I can do, see, this is the highest resolution I've got. I can actually tell it to look at every 10 points. So there's every 10 points for Earth. See? You can start seeing that we're getting not a solid line anymore. And we can do exactly the same thing for Venus if we want. Yeah. So you can sort of, hopefully, you can sort of tell, you can sort of see on the screen here that it's not a solid line anymore, right? Because I'm sampling every 10 points. Now remember, this is for 10 years of data too. So that's why they look like little what are those called? Oh, I forget what they're called. Because the whole orbit of the Earth and Venus, and actually all the planets, is actually precessing. It's slightly precessing. So positions always change. Now we can change the point size here. Maybe 10. Well, that's probably too much. Let's go like five times what they were. And that should be pretty solid again. Yeah, there we go. So that's kind of cute.
What's interesting is when we just did just the Earth, they had that wobbly orbit style. But when you did just the Earth and Venus, it's got some type of like crazy orbit between Earth and Venus.
Yeah, the wobble is there still, but as you recall, the data values for Earth in the z-axis are like in the thousands of kilometers or the hundreds of kilometers, right? And in fact, sometimes even tens of kilometers, right? So I think the most that the Earth moved along the z-axis was something like 10,000 kilometers, while with Venus, in fact, let's just look at plain old Venus. We didn't do that here. Let's look at just Venus exactly the same way that we did with Earth. So there's Venus. No wobble. No wobble at all. But you can see that let's sort of line up the z-axis. You see, that's going from about 6 million negative to 6 million positive. That's like 3 orders of magnitude larger than Earth's. So when we plot them together, scaling all this makes that wobbling thing almost go away, because the wobble is really, really small. You know, I mean, it's on the order of, you know, probably hundreds of kilometers, as opposed to thousands or millions. So it's just because of the scaling of the plot that you can't see those things. But anyway, so there's that. So now what we want to do is, as I said, we want to connect the dots. So for each point on Earth at the same time, the same day, I want to draw a line between the position of the Earth going around the sun and the position of Venus going around the sun. There's a lot of ways to do that, but I think the easiest way is going to be the following. I'm going to write a Perl script. So Perl is a programming language that is really, really cool. Let's see. Let's just call it ev.pl for Perl. And I've got to tell the system to use Perl. User bin Perl. Okay, so let's see if I remember all of this. So we're going to open, and let's call this Earth. So that is just a variable. It's going to be an input. You can specify like that. So this is all part of the Perl language. And argv of 0. So that is just going to be a file. I'm going to tell it to open that file. And then I'm going to have it read in everything. Oh. Again, I'm having to do this one-handed, so I'm going to do lots of typos here.
Get you a headset.
Yeah, I need to get a headset. Okay, so I'm going to call this, let's just call this Earth. So now I'm going to split up, right? I'm going to take this, and I'm going to split this up pretty much the same way I did with the plot, right? I'm going to split this up by comma. So each time it finds a comma, it's going to say, okay, here's one chunk, here's another chunk, here's another chunk, right? So Perl actually counts from 0. So this is column 0, this is column 1, 2, 3, and 4. So I want 2, 3, and 4. Go back here, and we're gonna so we're going to separate this by commas, and this specifies the input. Again, this is all part of the language, so I'm not gonna get into this right now. So let's call this ex of I equals Earth of 2, right? That was column 2, is that right? Whoop. 0, 1, 2, right? Column 2 is going to be our X, and then column, or our Y, whoop, come on, it's going to be column 3, and our Z is going to be column 4. I've got to specify a variable I, So this is just rudimentary Perl. There is nothing fancy here at all. There are lots of ways of doing this. This is just sort of the way I do it, right? So I've got a counter here called I, and I'm just going to fill up these arrays, EX, EY, EZ, with these values, right? Okay, so now I can close that file. Close Earth. Close Earth. And we're going to do exactly the same thing for Venus, right? So I'm going to take all of this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 of those lines. I'm going to grab them and copy them. And then I'm going to change this to Venus. Now, I don't have to do this, but it just makes it easier to follow. And so then let's change our variables here. So we've got new arrays, Venus, like that. Whoop. And Venus here, CW, Venus. So this is some of the stuff that I do every day. Okay, so, oh, and we want argv of 1. So argv is a variable that is just whatever is specified on what's called the command line, which is the command I'm going to give it in order to run this thing. Okay, so now we've opened Earth and we've grabbed our XYZ data and we've closed Earth, and then we've opened Venus and grabbed our XYZ data there, right? So then what I want to do is I want to tell GNU Plot to draw a line in between each point. So what I'm going to do is I'm going to create a loop. It's called the for loop. And I'm going to go from, specify a new variable called j. And j is going to go from 0 to I. See, I is the number of data points we have here, which is just going to be the number of lines in these files. So j plus plus, that, close that. So then what we're going to do is we're just going to print to the screen. And there's a lot of ways of doing this too. I'm just going to do it my way. It doesn't matter. Let's do exponentials. Any %e, %e. A new line. And it's going to be, oh, that's supposed to be a comma. We're going to call it EX, EY, EZ, that, and I need to change my I to a J because J is my counter now. So that's going to be the first line. So that is one data point, right? That's the position of Earth on one particular day. Now, if I want to draw a line in between those two, I have to do exactly the same thing on the next line, except it'll be Venus this time. So let's go V and V and V. Okay, so if I do that for all my data points up here, right, it's going to do Earth, Venus, Earth, Venus, Earth, Venus, Earth, Venus, Earth, Venus, right? It's just going to do that, and GNU Plot will then be able to connect all those points. So, last thing I have to do here is I have to make this file an executable file. So this is just a Unix thing. And so now let's run it. ev.pl, and we're going to call it Earth is going to be argv of 0. Venus is going to be argv of 1. And let's put the output of that into EV 1828. EV 1828. Let's take a look at it. So, oh, okay, well, there's only 2 columns there. That's not very friendly. I want 3 columns. Oh, haha. Percent. Okay. Here we go. Okay, so as you can sort of see, you know, most evident by the z-axis here. See, so here's Earth, here's Venus, Earth, Venus, Earth, Venus, Earth, Venus. And there should be, yeah, there are 7,308 lines, which should be twice as many as what we have. WC is a command called word count, but it also does line counts and character counts and all that. So 3,654 lines in each one of those files, totaling 7,308 lines, and that's exactly how many we have. We have here 7,308. So now, if we go back to GNU plot, so now, as you can see, I just have spaces in between these, so I don't have to tell it to look for commas anymore. GNU plot. So let's just plot this as is, and we'll just do points for now. Point, EV 1828, using columns 1, 2, and 3, because there are only 3 columns. Let's just do it with points first, because this should look exactly like what we saw before. Points, type 7, point size, 0.5, and color 8. So this should look exactly like the other one. Whoop, we didn't do a 3D plot. Yeah, looks exactly like the other one, which it should, because it's the same data. It's running a little bit slower, as you might be able to tell, because it's having to replot this every single time it moves. So, you know, it's a little bit of an effort here. I just want to square this up, square up the square. Let's see, can we make this a little bit wider, maybe? It looks pretty square. And then, as you can see, we're doing that. Okay, so now let's connect all these points, right? These are actual points. I probably can't see individual points because it's for every single day. Yeah, we still can't really see it, but those actually are points. Let's some lines in between them then. There's kind of thing. Point type 7. Let's do a point size of 0.5 and a line width of 0.1. So we'll have big points and thin lines. And for now, let's just leave the line color as it is. So there we go. So that's a little dense, right? I mean, it's absolutely gorgeous, right? But it's a little dense, but it's pretty. pretty nice. And sort of, you know, rotate this around. And this is actually how I make some of the movies that I do. I just make a GNU plot script to create all of these, and then I combine them into a movie. It's kind of nice. Let's do a point size of 2. It didn't change much. A line width of 1/10 of that. Kind of cool. 5 maybe. Pretty nifty. Now I'm trying to think about how to put some color into this thing. And wow, we're already coming up on the hour. It's absolutely amazing how fast time flies. Let's do this. I'm going to go back to what we originally did, 0.5 and 0.1, and let's look at like every 10 again. So then it's not going to be quite as dense. Oh, it's not very dense at all. Oh, what happened? I don't know. Oh, I know. So this file is sort of a base 2, so I need to change this to like an 11, I think. See if that... Yeah, there we go. Let's increase this. And let's make the point size and the line width the same. And you know what? Let's get rid of those grid lines now. We don't really need those. Order key picks. I think it'll make it a little bit larger too, so we can really...
Can you disprove Tom Van Scotter's question about if the files had the same number of lines?
The individual files, yes, have exactly the same number of lines. You see here, Tom, where it says 3654 for each one of these files. So yeah, that's 10 years worth of data. One data point per day for 10 years. I don't know why it's 4. I would have thought that would have been either 2 or 3. So I'm not quite sure what's going on there. I think, oh, it's probably because it includes the first day of 2028. So there's an extra 2 days there on each one. So I think that explains that. So yeah, I hope that answer your question. Okay, already answered. Yeah, isn't it beautiful? It's just absolutely amazing. Here, I can make that a little bigger. View 0.51. Is that cool or what? It's actually nice to rotate it like this with my keys. See all kinds of interesting patterns in there. Ooh, that's cool. Look at that. As you can see, you know, I can and do spend hours messing with this, days messing with this stuff. Let's do every 7 instead. So these are the actual physical relationships between the Earth and Venus. This is it's artistic, but it's also real data, right? These are the orbits of Venus and Earth, and I'm just showing the relationships between them. That's all I'm doing here. But it's fantastic, I think. So if we had a little bit more time, I would get into colorizing this and all that. Let's just do one more thing. There's one more thing that I sort of wanted to do, and that is plotting the barycenter of these guys. Instead of drawing lines in between these points, let's just create a new set of points, which is the barycenter, the midpoint between points, and plot that instead. That's pretty easy to do. So we can use the same code. We'll just put it in a different. Well, can we do it in a different column? No, we're going to have to comment these out. No big deal. So it's all I want to do is I want to take the midpoint between X and Y and Z. So that is super easy. All right, it's just let's call it M equals. It's just this. It's the Earth X plus the Venus X divided by 2. Right, that's the halfway point. And let's do that for Y and Z. So there's Y. Oh. Y. 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 And Z. Z. And Z. All right? Okay, so let's print those out. Print. And I guess we can do it in exponential as well. It doesn't really matter. Oh, we need X, Y, and Z. It needs to be %E, %E, %E. Oh, new line. And it's going to be MX, MY, and MZ. That. All right, so that's just the midpoint of X, Y, and Z. I think that's right. Okay, let's run that. We'll call it mid. Uh-oh, all zeros. What did I do wrong? Oh, that was kind of stupid. It has to be J. J's our counter here. It can't be I, because I isn't changing. Okay, there we go. There we go. Let's see what that looks like. I don't quite know what to expect here. Oh. Well, we can do lines, points. It doesn't particularly matter. Let's just do points for now. Point type, size. 1, 2, 3, and it's called mid, right? Mid. All right, I don't know what to expect here. Huh. Oh, every 7. Let's look at every single one. Wondering why that wasn't. Ooh, that's kind of cool looking. So again, let me square this up a little bit here. Oh, that looks pretty square, actually. Let's make it a little bit bigger. And then I'll get rid of the axes again. Let's see. I can look at my history, and, you know, as a programmer, you learn all kinds of tricks so you don't have to type things over and over and over again. There we go. It's a little big. Extends a little bit too far. Let's go 5. That's pretty cool looking. Rotate these around a little bit. So those points are the barycenter points, or the midpoints between the two planets as they orbit the sun over the course of 10 years. Pretty cool. We can make those lines instead. Line width 0.5, and we'll make this lines instead. Oop, oop. Oop. There we go. So kind of interesting. You can see that the lines don't always overlap, right? There's a little space in between here and here. You see that? So, you know, nothing is perfect out there. There's always a little bit of funny business going on to make things never line up exactly the same way every single time. But that's, I think, what makes, you know, one of the things, you know, that makes the universe really interesting. Now that's kind of a cool motion there. Isn't that cool? Now, as I said, you know, I could keep going here and play with colors, you know, have, you know, make a color of a line depending on, you know, whatever, right? I mean, if we went back to like the JPL Horizons website and actually got like the velocities of these planets as they moved around, I could actually change the color of the line as the velocity changed, right? That would be one thing interesting to kind of see. So yeah, lots of neat things to do artistically here with all of that. But yeah, I thought that we could do this tonight just to sort of play around with some astronomical data and, you know, turn it into art. I thoroughly enjoy this. One of the cool things I can do too, right, is I can take this exact same data and I can turn it into sound. so we can actually see and hear this data as well. So, and the sound is yeah, I guess kind of interesting. Kind of interesting. So, all right. Well, I think that's about it for today. Hope you like that. Earth and Venus. Now, we can choose any astronomical objects we want. It doesn't have to be. I'm gonna stop sharing my screen. The cool thing is that this doesn't have to be sun-centered, right? We could do exactly the same data, but make it Pluto-centered, or Ganymede-centered, or we could choose different objects. There are thousands and thousands and thousands of asteroids. There are comets, of course, all the planets, minor planets. There's just a huge amount that can be done. It just takes a little bit of time, writing a little bit of code, and I think it's pretty fun. So, all right, I guess I will leave you with that.
Yeah, that is some interesting stuff using Perl and stuff.
Yeah, and what I like about it, right, is that it's showing relationships, and that's what actually the universe is all about, is relationship. How do I relate to you, and how does the Earth relate to Venus and all the other planets and asteroids and comets, and all this data is there. And it's actually really easy to manipulate. Like you can see, you need to know a little bit of code, and you need to be able to use these tools. But once you get over that hump, it's extremely easy and extremely fun, and it can take days and days and days away from your life. All right, you guys, I'm going to let you go. So have a great evening, a great day. And you know what? Before I let you go, I'm going to look at the satellite loop one more time to see if it looks like it's going to be clearing up. Because if it's clearing up, then I'm probably going to live stream. So I'm looking at my satellite loop now. Oh no, those high clouds. No, those high clouds have intruded. I'm going to go out, of course, and actually do a real visual. The satellite loops I trust, but I also trust my own eyes much more. So I'm going to take a look, but it looks like I am clouded out for tonight. I think tomorrow it might be clear as well. So first night that I have clear, I've got some things to do. So I'm going to do them. I'll probably live stream it. It's probably not going to be incredibly interesting, but you can come along if you wish. It'll be a little bit late for most of you, but if you want to be up, that's cool with me. All right, I'm going to get out of here. Take care, everybody. I will see you in a little less than 23 hours. See you later. Bye.
Later.